Hello friends, welcome to b.sc first year class. Today we shall start our mathematics paper and we have to study two papers for first semester. The paper number MAT 101 is Differential Calculus and another paper is MAT 102 which is Differential Equations. And between these two papers we shall start today the first paper 101 as Differential Calculus. Last year we have studied the part of Differential Calculus. Earlier we have studied functions and limits of functions, derivative, integration, that also we have studied last year. The function is a relation, so we shall consider if f is a function between two sets from A to B, such that every element in set A, we denote that element by A, is related to an element in B, and suppose that element we shall denote f of A. That means this element A has image f of A. A is related to f of A because the function is denoted by f. And similarly, if you consider this, suppose this A changes to A plus H. Another element we shall consider as A plus H, some increment in A. And then its image will be, or that element will be related to the element under f of A plus H. So these are the two elements we have considered. A has image f of A under f and A plus H has image f of A plus H. Now what we shall consider is the difference in these values. And you see the difference in these values is f of A plus H minus f of A is the difference. So here the difference is f of A plus H minus f of A. And what is the difference here in this these values? A and A plus H. That is A plus H minus A, which is H. So that means A has increment in A as H. A changes to A plus H. And while this is the change, there is corresponding change in function value from fa to f of A plus H. Now we shall consider the ratio of these differences. The difference between these two values, that is f of A plus H minus f of A. This difference is divided by this difference, but this difference is only H. And this is the ratio in their changes, relative changes. As there is change in element of A, there will be corresponding change in element of f of A. And thus these changes, we have taken their ratio. And now what we shall consider is, suppose this change is very small. This change is very small, change in A is very small, that is change in domain. Values in the domain is very small, means this H tends to 0. And we take its limit as H tends to 0. And if this limit exists, then we say this is the derivative of f at point A. And we denote it by f of A. So this is the meaning of derivative that we have studied earlier in 11th or 12th standard. And now what is the meaning is as corresponding changes we are considering and their ratio. So for example, if you consider an example of a factory, and suppose these are the workers or employees or laborers. As there change in the number of workers or laborers, there will be change in production. Production will increase. If the laborers are increased, the production corresponding production will increase. And thus increase in the production divided by increase in the labor, number of labors, and if the change is very small, the increase in labor is very small, that gives the derivative of the function. Similarly, if you consider agriculture example, then yield of a crop, as the land increases, the production increases in agriculture also, and increase in production divided by increase in land, its ratio when the increase is very small will be the derivative. So this is a derivative which is denoted by f dash of a, and thus this definition we have studied earlier, and we will write it again. Definition of derivative. Let f of a is the function. If the limit h tends to 0, f of a plus h minus f a, if this limit exists, then it is called the derivative. Derivative of the function fx at x is equal to a, and is denoted by f dash of a, and thus f dash of a, or that is limit h tends to 0 of f of a plus h minus f a divided by h is equal to f dash a, or we will write this as f dash a. F dash a is equal to this. So this is the definition of derivative. Now another notation can be considered like this. Suppose here this point is taken as x, and so corresponding image will denote by f value. So a is related to f of a. So similarly, x will be related to f of x. Now what will be the changes here? You see, the change will be fx minus fa. We are taking a plus h as x, so this is fx minus fa. And as h tends to 0, this x will tend to a. So instead of a approaches x, we now have to consider x approaches a. And in that case, here, see, we will consider a plus h is equal to x. Put, or yes, it will be considered as a plus h is equal to x, or x is equal to a plus h. We have considered this x as a plus h. As now h tends to 0. As h tends to 0, what will be the value of x? When h is 0, x will be a. So when h approaches 0, x will approach towards a. X tends to a, and therefore we use these values in the above limit. So this limit is the derivative, and we use it in above limit. So therefore we have f dash of a. Now what will be f dash of a? Limit h tends to 0, but h tends to 0 is now replaced by x tends to a. As h tending to 0, x will approach towards a. X becomes equal to a means x approaches towards a. And therefore we change this limit as limit x tends to a. And we are using these values in this limit. H tends to 0 is replaced by x tends to a. And what is f of a plus h? A plus h is x. So this is f of x minus, there is no change in a, divided by, and what is h? Now h value is to be obtained from this. H is x minus a. So or here we can write h is equal to x minus a, and thus this value is changed as x minus a. So this is the another definition for derivative. Now both are important. We will remember both these. So this you have studied earlier last year, and now this is to be also remembered. So this is the derivative of f of a. F dash a is equal to limit x tends to a fx minus fa divided by x minus a, and that is the meaning of derivative. Changes are considered relative rate. So derivative measures the rate of change. So here that is change in the function value, and here it is change in the x value. And the ratio when the change is very small in x, change in the domain is very small, is called the derivative. Now we have studied that there are two types of limits. As what is meaning of x tends to a, see x is approaching towards a. Suppose this is a real number line and a is this value. X is approaching towards a means x is becoming nearer and nearer to a. But there will be two positions of x. X will be on the right side of a, and then x will take the values closer and closer to a. And this we say x tends to a from right. And in this case we write this as x tends to a from right, means this is the notation, from plus, a plus, from right. And here x is greater than a. X is on the right side of a, therefore x is greater than a, and x approaching towards a. This is the right hand approach. And secondly, we may consider, suppose this is a and x is on the left side of a, and x approaches towards it. In this case, we shall say x tends to a from left, and that the notation here it is not minus a or not plus a, it is only the notation. So if we write plus here, that means x tends to a from right, and this is from left. So plus means from right, minus means from left, and in this case x is less than a. So that means x lies on the left side, then its value is less than a. So that is the meaning when x approaches towards a. The meaning can be considered as, suppose there is a railway line, single railway line, and now if you consider this is a railway line, and there are three stations we may consider. Suppose this is A, this station is B, and this station is C. Now if there is an announcement that a train approaches station B, train approaching station B, means there are two possibilities. The train can come from station C to station B, or the another possibility is the train can come or can arrive from station A to B. So that is the case here. If A is there, then x is approaching towards A, means x is becoming closer and closer to A. If x is on the right side and it approaches towards A, we say x tends to A from right, and write this as x tends to A plus. Or sometimes it can also be denoted by x tends to A plus 0, but we will use this notation. And if x is on the left side of A and approaches towards A, then we say x tends to A from left. That are the two notations. And again, when a limit exists, we written here, if this limit exists, then it is the derivative of the function. There are, as h tends to 0, the derivative we can consider this definition. Limit h tends to a. And we have seen there are two-way approaches towards it, from left or from right. And thus there will be two limits, right hand limit and left hand limit. And if these two limits are equal, then the derivative exists, otherwise not. Now we define the right hand derivative and left hand derivative. if we shall consider limit x tends to a from right, f of x minus f divided by x minus a. If it exists, is called right derivative. Right derivative of f at a or fx at x is equal to a and is denoted by r f dash a. So this is the mean. Or thus therefore r f dash a is equal to limit x tends to a from right, f of x minus f of a divided by x minus a. So what is the change? The definition of derivative remains the same. Limit x tends to a, fx minus fa divided by x minus a. Only the limit is having different approaches, right and left. Limit x tends to a is taken limit x tends to a from right, and therefore it is called right hand derivative or right derivative, and r stands for right hand derivative. Similarly, there will be left hand derivative. So if this limit as x tends to a minus means x tends to a from left, the left hand derivative is denoted by L f dash a, and is what will be this L f dash a? Only the change in limit x tends to a from left, f of x minus f of a divided by x minus a. So this is the main definition, and these are the parts, right hand derivative and left hand derivative. Only their change in limit x tends to a from right, limit x tends to a from left. And why these we are considering separately? Because x tends to a has two meanings. X approaches a from right, x approaches a from left, and therefore corresponding to these approaches, these limits, there will be two derivatives, right hand derivative and left hand derivative. Now when the derivative will exist, f dash a will exist if and only if these two are equal. Last year we have studied limit. When the limit of a function exists, limit is only one. There cannot be two different limits of a function. And limit exists if the right hand limit is equal to the left hand limit. So we consider f dash a exists if and only if r f dash a and L f dash a both exist, and r f dash a means right hand derivative is equal to left hand derivative. So this is important. So this we have to remember. When the derivative exists, if and only if r of f dash a is equal to L of f dash a, means right hand derivative is equal to left hand derivative, then the derivative exists. And another notation we have studied for derivative is dy by dx. If derivative of y with respect to x is denoted by dy by dx. Now we shall consider some problems on whether to check whether the derivative exists or not. And these problems we shall consider from the book. The book, recommended book for your paper is book of Differential Calculus by Shanti Narayan. So this is the recommended book, Differential Calculus, Shanti Narayan and P.K. Mittal. From this we are considering problems. Now we will consider this example as, or before that we will have a result or as a theorem, and that is differentiability implies continuity. These are the properties of function, continuous function. When a function is said to be continuous, we studied it last year. So fx is said to be continuous at point C if limit f is continuous or fx is continuous at x is equal to c if limit x tends to c of fx is equal to f of c. This is the simple definition of continuous function. Limit is equal to the value of the function. Limit of fx as x tends to c, the point may be c or a, is equal to f of c. Then the function is said to be continuous. We just define what is the differentiable function, and the differentiable function implies continuous function. If function is differentiable, then it is continuous. That is the meaning of this. So we write this as a theorem. If a function f is finitely differentiable at point C, then it is continuous at C. Or I may simply say, if a function is finitely differentiable at a point, then it is continuous at that point. Or that means a differentiable function is continuous. So you have studied this result also in 12th standard, but we will consider it again. Let a function f, let a function fx is or be finitely differentiable. Finitely differentiable means it has finite derivatives. Or it is differentiable finite number of times. First derivative exists, second derivative exists, nth derivative exists. So n times it is differentiable. Finitely differentiable at a point C. Or therefore f dash c exists. And what is f dash of c? By definition, we will use the earlier definition in terms of h tends to 0. Limit h tends to 0, f of c plus h minus f of c divided by h. This is the definition of derivative. Instead of a, we are using here c point, and this is the first definition we have written. Then we have converted it in terms of x, fx minus fc divided by x minus c. And now we will consider as, suppose this as 1, the result 1. Now we consider the difference f of c plus h minus f of c. We can write this difference of two values of f as f of c plus h minus f of c divided by h into h. We have multiplied and divided by h. H is not equal to 0. And now we take the limit on both sides as h tends to 0. Taking limit as h tends to 0 on both sides. We get, see limit of this, limit h tends to 0, f of c plus h minus f of c is equal to right side, limit of the right side means or we can just write limit h tends to 0 of the whole right side I shall write in brackets c plus h minus f of c divided by h into h. Now this is the right side is equal to, this is equal to limit. There are the theorem on limits we shall use, limit of fx into gx. Limit of product of two functions is limit of first function into limit of second. So that means limit of f of c plus h minus f of c divided by h into limit of h or into limit h tends to 0 of h. Separate limits we have written. But what is the limit of this? The first is, here it is, limit f of c plus h minus f of c divided by h, and that is f dash of c. So this is equal to f dash of c into, and what is limit of h as h tends to 0? When h is becoming 0, this limit becomes 0. So because it is h only and it is tending towards 0, it becomes 0. So therefore this is into 0. And f dash of c into 0 is again 0. So this is 0. So finally what we have, limit of this difference is 0. And therefore we can say as limit f of c plus h minus fc, or here it is limit h tends to 0 f of c plus h minus f of c, and this is equal to 0. So therefore this limit also is the limit of the difference, that is limit h tends to 0 f of c plus h minus limit h tends to 0 f of c is equal to 0. Limit of difference is equal to difference of limits. And further, limit of, we take this term on that side, limit h tends to 0 of f of c plus h is equal to limit of f of c as h tends to 0. But you see, this is limit of f of c as h tends to 0 is f of c. C is fixed number and point, and it does not depend on h. Whatever h is tending towards 0, it does not change f of c, and it is constant with respect to h. There is no h, and therefore this limit is same as f of c. But here we can't write like this f of it. Here it is h, so therefore we have to write the limit. Here there is no h, and therefore limit of fc as h tends to 0 is same as f of c, and this is equal to 0. Now we take this minus f of c on right side, and that gives limit h tends to 0 f of c plus h is equal to f of c. So this result we have obtained, and what we are going to say is function is continuous at x is equal to c. And to get the exact definition as we have studied, what we shall do is put c plus h is equal to x. Now put x is equal to c plus h, or c plus h is equal to x, and therefore as h tends to 0, If h is tending to 0, x will tend to c. X tends to c. And thus the above limit becomes, therefore we have limit x tends to h tends to 0 means x tends to c of f of x. C plus h is x. These are the changes we are doing in the above limit, and this limit we are writing here. X tends to c f x is equal to f of c. And this is the definition of continuous function. When we say a function is continuous at x is equal to c, if limit x tends to c of fx is equal to f of c. So this shows that fx is continuous at x is equal to c. And thus a differentiable function is continuous. So we have assumed the function is differentiable. That means this we have denoted by a dash of c. If it is differentiable, it becomes continuous, and thus differentiability implies continuity or gives continuity. Function is differentiable, then it is always continuous at that point only. It depends on the point. So therefore, or thus differentiability implies continuity. Property of function to have derivative is said to be differentiability. Implies or gives continuity. Or the meaning is a differentiable function is continuous. Now we shall write a remark here. The converse of this, what is the converse of this? Whether continuous function is differentiable or continuity implies differentiability. And that converse is not true. The converse of above theorem is not true. Means a continuous function may not be differentiable, or that is a continuous function may not be differentiable. Sometimes maybe, but not always. And if it is always, then we can say that it is true. When we say a result is true, the result must be true for every value. But here, if a function is continuous, it may not be differentiable. And example we shall consider, as we know this example also, we have studied this example. For example, if you consider absolute value function, counter example for this. For example, fx is equal to mod x is continuous. This function is continuous at x is equal to 0, but it is not differentiable. Not differentiable at x is equal to 0. This is the example we shall see. The solution or the proof can be considered here. First part, fx is continuous at x is equal to 0. We have fx is equal to absolute value function mod of x, and mod of x, this is important function, we should understand its definition correctly. So mod of x has two values, either x or minus x. When we consider it as x, if x is greater than or equal to 0, non-negative, 0 or positive, then its value is same as x, and it is minus of x when it is minus of x if x is negative. Less than 0 means negative, greater than 0 means positive. So it has the two values according it is positive or negative or 0. When it is 0, then it is mod 0 is same as 0, and if it is greater than 0, then mod x is same as x, and when it is negative less than 0, then mod x is equal to minus x. For example, we have, see, mod 0 is same as 0 by the first definition. It has two definitions, and if I consider mod of 3, then 3 we have to check whether this is greater than or equal to 0 or less than 0. 3 is greater than 0 means in this first case it lies, and it is to be considered same value as x means it is 3. Now, but if I consider mod of minus 5, now what is mod of minus 5? Minus 5 is negative, less than 0, and therefore we have to use the second definition. And what is the second definition? Mod of x is equal to minus of x. What is x here? Minus 5. Compare this, x is minus 5, and therefore this is negative of minus 5. Take negative of this if the number is itself negative, but minus of minus 5 is same as 5. So you note this, we have to understand the definition correctly, and therefore if it is negative, negative of negative, that becomes positive. That means modulus function or absolute value function is always positive. If it is positive number, then it is the same, but if it is negative, then take its negative, then it becomes positive. So that is the meaning of absolute value function. Now we shall consider that fx is continuous at 0. First thing, fx is continuous at x is equal to 0, because the function is defined in two ways. We have to find out the two limits, and the left hand limit we will write first. Our right hand limit we shall consider. Limit x tends to 0 from right of fx is equal to limit x tends to 0 from right of fx, that is mod x. And when x tends to 0 from right means x is greater than 0. X is on the right side of 0 means x is greater than 0, and therefore x is greater than 0, mod of x is x, and this value is limit x tends to 0 from right of x, and that is 0. X tends to 0 is 0. Now what about the left hand limit? Limit x tends to 0 from left of fx is equal to limit x tends to 0 from left of mod x, and here you see limit x tends to 0 from left. Now what is x tends to 0 means x is less than 0, or x lies on the left side of 0, and when x is less than 0, the value of mod x is minus x, and therefore this is minus of x. But you see, minus sign is constant, can be written separate, and limit of x tends to 0 of x is again 0. Remember, this is not minus 0, it is only x tends to 0 from left, and minus of 0 will be the limits value. It is minus 0, but 0 is neutral, plus 0 is same as minus 0, and it is 0 only. So therefore this is 0. Also, what is f of 0? Three values we have to check for continuity. Left hand limit, right hand limit, left hand limit, and the value of the function at 0. Now what is f of 0? That means function's value at x is equal to 0. X is equal to 0 is in this interval, first definition. X is equal to 0. And x is equal to 0 means mod 0 is equal to 0, or we have seen earlier. So this is mod of 0, and that is equal to 0. Now you check. The right hand limit is 0, left hand limit is 0, and value is also 0. All the three are equal, therefore the function is continuous. So this definition you have studied last year, and according to that the function is continuous, or we may mention it as all these are equal. So that is right hand limit is equal to left hand limit, and that is the value of the function. Limit x tends to 0 from right of fx is equal to limit x tends to 0 from left of fx is equal to f of 0, and all are equal to 0. Therefore fx is continuous. Continuous at x is equal to 0. Now second thing is differentiability at x is equal to 0, or derivability at x is equal to 0. Or you may write simply derivative at x is equal to 0. Differentiability means derivative at x is equal to 0. Now we shall find first the right hand derivative, r f dash 0. By definition, this is limit. What is the r f dash? We have here written the definition. R f dash of a we have written, and that here is limit x tends to 0. The point is 0, so therefore x tends to 0. Fx minus f0 divided by x minus 0. So that is the definition of the derivative, and that is r f dash of a. We have defined earlier. R f dash of a is equal to limit x tends to a f of x minus f of a divided by x minus a. Here a is 0, so fx minus f0 divided by x minus 0. And now you see this is 0 from plus, 0 from right. X tends to 0 from right. That is to be written. And remember this is the definition for right hand derivative. To check the function is differentiable or not, what we have to check, as like in continuous function, we have checked the right hand limit is equal to left hand limit, then the limit exists. Similarly, if right hand derivative is equal to the left hand derivative, then the derivative exists, and we say the function is differentiable. Here we say the function is continuous. So these are the two definitions, and this is limit x tends to 0 from right. Now what is fx? Fx, you see, we have mod x, and similarly this will be mod 0. f0 means put x 0, it is mod 0, and divided by x minus 0 means x, or therefore this is limit x tends to 0 from right, and this mod 0 is 0, so therefore it is only mod x divided by x. And what you see, what is the mod x when x tends to 0 from right? X tends to 0 from right means x is greater than 0. See, 0 is here and x is on the right side of 0. So that means x is greater than 0. And therefore, this is equal to limit x tends to 0 from right. And when x is greater than 0, its value mod x is equal to x. So therefore, this mod of x is equal to x divided by x. Since mod x is equal to x, x greater than 0. And what is the mod x divided by x? It is 1. So limit of 1 is 1, or that is equal to limit x tends to 0 plus or from right and is equal to 1. So this is the right hand limit we have obtained. So that is, I shall write here, r f dash 0 means right hand derivative of f at 0 is equal to 1. Now we shall find out the left hand derivative. For left hand derivative, next, L of f dash 0 means left hand derivative at 0, and that is limit x tends to 0 from left of fx minus f0 divided by x minus 0. Same, only there is change in the limit. Here from right, here from left. And this is limit x tends to 0 from left. What is f of x mod 0 divided by x minus 0, or that is again limit x tends to 0 from left mod x divided by x, same as in that. And now you see what is mod x value when x is tending towards 0 from left, and x tends to 0 from left means x is on the left side of 0, means x is less than 0, and when x is less than 0, what is mod x? That is minus of x. Mod x is minus x, and here we have to use the value as minus x. So this is limit x tends to 0 from left minus x divided by x, and x cancels here because x is close to 0 but not 0, and what remains is minus 1. So this is limit x tends to 0 of minus 1, and that is equal to minus 1, or thus this is left hand derivative of f at 0, or L f dash of 0 is equal to minus 1. Now what is our observation? The right hand derivative of f at 0, r f dash 0 is 1 and L f dash 0 is minus 1. So these are not equal, and when these are not equal, the derivative does not exist. We have written earlier result when f dash a exists if r f dash a, the right hand derivative of f at a is equal to the left hand derivative of f at a, then only the derivative exists, otherwise not. And therefore we see from 1 and 2, or yes, we may suppose this as 1 and this is 2. From 1 and 2, right hand derivative of f at 0 is not equal to left hand derivative of f at 0. 1 is not equal to minus 1. Therefore, our conclusion is f dash 0 does not exist. When it exists, if these are equal, then it exists. And f dash 0 does not exist means fx is not differentiable at x is equal to 0. So therefore fx, and fx is mod x, does not have the derivative. Fx is not differentiable. Not differentiable. At x is equal to 0. And thus mod x is continuous. We have seen earlier it is continuous, but it is not differentiable. And therefore a continuous function may not be differentiable. And hence mod x is continuous at x is equal to 0, but not derivable or differentiable at x is equal to 0. So this is the meaning of the theorem. Differentiability implies continuity, but continuity does not imply differentiability. So what we have studied is the definition of derivative, and there are two types of derivatives because there are two types of limits, right hand limit and left hand limit. Similarly, there are two types of derivatives, right hand derivative and left hand derivative. So definition of both these, derivative, right hand derivative and left hand derivative, we have to remember, and we have to check whether the function is differentiable or not by obtaining its two derivatives, right hand derivative and left hand derivative. If they are equal, then the function is differentiable, and if they are not equal, then the function is not differentiable at that particular point. Here the point is 0. So the function is not differentiable at 0, but it is differentiable for other point, x is equal to 1, 2, etc. Other many points it is differentiable. So this is about the definition of derivative. and relation between derivative and continuity. So the remaining part we will continue. Remaining part we shall have to consider. We shall consider problems on finding whether the function is differentiable or not. That we shall consider in next lecture. Thank you.